Hi guys, today we're going to talk about how to determine if a given graph represents a function or not, or if it represents just a relationship between the x and the y variables. So we're going to go through a couple different types of graphs and determine if they represent a function. So just to kind of go over again, a function is a relationship where each input has only one output. We can kind of think of this as a soda pop machine. If you put money into a machine and click a button, you want the same soda to come out of the machine every time you click the same button. So for example, let's say you want Dr. Pepper. If you click the Dr. Pepper button, you expect a Dr. Pepper to come out every single time. That represents a function if a Dr. Pepper comes out every single time. Now let's say you hit the Dr. Pepper button and a Mountain Dew comes out every time. Well, no, it's not the soda that you wanted, but it was consistent. Every time you pushed the same button, the same product came out. Now, let's say you press the Dr. Pepper button, and the first time you get a Dr. Pepper, you press the same button, you get a Mountain Dew. You press the same button, you got a Sprite. That is not a properly working function, because every time you press the same button, you inputted the same value, you got a different soda or a different output. So that's what we're going to look at with our graphs. All right, so let's take a look at these three graphs here. So let's take a look at 19. And what we want to do is look at the different inputs or the different x values. So I'm going to write inputs right here. And then we want to determine our outputs, our y values. So what we want to make sure is that for every input, there is one and only one output. So we can just go ahead and pick an input value to look at. Let's say we are going to choose -2. So if we look at -2, we're looking right here on the x value, and we can see at this point there's one and only one output. There's one coordinate point there. So at that point, we're looking pretty good. However, let's take a look at, let's say, +2. So our input is +2, and we want to look at the graph for our y values. So we have this one y value at +2, and this second y value at -2. This means that for our one input value for this +2, we had two different output values, which means that this is not a function. Okay, let's look at our second graph here. We want to look at each one of our input values. So if we start with -2, we have one input value. If we look at -1, we have one output value. If we look at 0, we have one output. +1 and +2, we all have one output for every one of our x value inputs. So in this case, our second graph is a function. All right, let's take a look at our third graph. For every one of our inputs, so for every one of these x values right here, we're wanting to see one and only one y value. And if we look at our line, we can see that we do have one and only one output value for every one of our input values. So yes, this would be a function. We can do what is also called a vertical line test to determine on a graph. And in order to perform the vertical line test, all you have to do is hold your pencil vertically across the paper, so straight up and down, and slide it across the graph. If at any point the line or coordinate points on the graph touches your pencil at two places or more at the same time, then it is not a function. So that's an easy way that we can test for graphs. Let's just look at a couple more examples so you really get a good understanding of how to determine if something's a function or not, just looking at the graph. All right, so this first example here, we have a full circle. we can use the vertical line test. So take your pencil, hold it straight up and down vertically across the paper, and slide it across. If it touches any part of the graph at two places at the same time, it is not a function. So we can see if we scanned a line, a vertical line straight across here, let's say at this point, it is touching at two places at the same time, which means this guy is not a function. And if something is not a function, we call it a relationship. Just because there is still a relationship happening between the x and y variables, but there is not a one-to-one correspondence between every input having only one output. All right, for graph number 23, if we do our vertical line test, we scan across the whole graph left to right, we see that we don't touch two places at the same time. So this one is going to be a function. All right, our final graph, number 24. If we use our vertical line test and we scan across, we see that at a couple different places here, we're touching the graph at two spots for the one y value at 1. We're also touching two places at 0 and the x value is 0. And so this means we are not a function. All right, so that looks great for graphs with a lot of lines. We can use our vertical line test to help us determine if something is a function or not. And remember, something is a function if for every input there is one and only one output. All right, let's look at these two graphs. We call these discrete graphs because they are discrete points. They are not connected with any lines. They are just multiple coordinate points on a graph. So let's take a look at number 5. Let's look at all of our different coordinate points. So at -2, we just have the one coordinate point here. At -1, we have this coordinate point up top. At 0, we don't have any coordinate points. At 1, we have 2 coordinate points. Uh-oh, that gives us a problem. When x equals 1, we touch the graph at two places at the same time. This means that we are not a function. So even though graphs might just have separate coordinate points, does not necessarily make them a function if there's two outputs for one input. All right, let's look at our last one, our vertical line test. So at -2, we have this one coordinate point. Our next coordinate point happens when x equals 0, and that's the only coordinate point. When x is +2, we just have this one coordinate point, and when x is +3, we have this one coordinate point. So since there was only one output for every input, this is a function.